Perfect. All right. Let's go ahead and continue, guys. I need a quiet, please. Thank you. So today we're going to go ahead and write equations of parallel lines. We're going to go ahead and just still focus on what we did yesterday. More specifically, we're going to go ahead and focus on writing equations. So I'm going to go ahead and take you guys into a trip out to Algebra 1, just for a little bit, refresh your memories, so we can go ahead and do our next topic here. So writing equations of parallel lines, that's our learning objective today. All right, so with that said, do you guys remember what we went over yesterday? We stated that if we have parallel lines, they have to have the same what? Slope, or two lines are parallel if and only if they have the same slope. So we reviewed everything on slope, rise over run, and then we also saw it as two coordinates, and we were able to determine what a slope was, and then we compare and contrast and see if two slopes were parallel or not, depending on what their values were, and saw if we had a beautiful parallel line here. So today we're going to go ahead and go into forms of linear equations. So there's three forms, 1, 2, and 3. And our first form is the one that we call slope-intercept. Do you guys remember that one? What do you think it is? Y equals mx plus b. So we're going to go ahead and see this beautiful format again. So slope-intercept form, y equals mx plus b. Write this down, guys. Now, my second form that we're going to see is standard form. Very similar, yet different, because my x and my y are on the same side of the equal sign. So this time they're on the left side. And that beautiful constant is on the right side of our beautiful equation. But it's called standard form because both x and y are on the same side of your equal sign. And the last one, we're going to go ahead and use this one mostly when we have to write the equations, depending on what we're given. This one's called the point slope form. And what that one does is that we use a point and a slope in order for us to write the equation of a line, okay? So we have slope-intercept form, standard form, point slope form, and I'm going to go ahead and discuss about the different parts of each of the formats here. Okay, make sure you guys copy this down. All right, so just to clarify, guys, whenever we have equations of parallel lines, we're going to go ahead and have a line parallel to another only if they have the same slope. So if it were to be given as a graph, we can go ahead and check its slope. I'm going to go ahead and select 2 points from here to here. What is the slope of the first line? What's our rise? 1, 2, so it's 2. What's my run? 1. Now let's go ahead and select another 2 points on this side. Let's select this one and this one. What's my rise? 1, 2. What's my run? 1. So are these two parallel? Yes, they are. So I need to make sure that my slopes are the same. Okay, so that's what we're going to go ahead and continue to use or apply here. That same idea. Okay, all right. No, ya lo tienen. An equation is parallel to another line if they share the same slope. Okay, now I'm going to go ahead and start with slope-intercept form. This one states that we have y equals mx plus b. And I want to talk about this one, my little friend here. What this one's doing is that we have our y isolated. So y is isolated, meaning that we solved for y. So y is isolated, meaning that we solve for y, and the rest of the terms or the parts of our beautiful equations are on the right side. Now, mx, our beautiful m, is going to continue to represent our beautiful slope. So slope is going to be in front of our x. Whenever you identify that term with an x, that's what we're going to have as a slope. Okay? Now, my y-intercept, we're going to go ahead and see it later on again, but we're not going to use it today. Our y-intercept tells us when our beautiful line intercepts or it crosses that y-axis. So that b is what we call the y-intercept, okay? So whatever constant is adding or subtracting, that's what we're going to go ahead and consider that to be. So we're going to use this format to help us identify slopes and then write beautiful equations. So, ready for our first example? Okay, yes, we are. Here we go. Example number 1. Let's go ahead and identify the slope of the line parallel to the following equations. My first equation is y equals 5 over 6x plus beautiful 1. Okay, write this one down, guys. Listos? All right. See? All we have to do is identify the what? The slopes. So what do we know about slopes that are parallel to each other? They have to be what? Equal. They have to be the same. So let's go ahead and identify the slope. What is the slope in this equation? 5x over 6. So what is the slope parallel to that beautiful line? 5 over beautiful 6. Not too bad, huh? No? Okay. All right. Try the second one. B. Go ahead and identify your beautiful slope that is parallel to that line. Go ahead and tell your neighbor. All right. Let's see. Let me pick somebody else. Who's ready? Who's not ready? A ver, Daniel. You ready? Find the slope that is parallel to that. Negative 6 over 7. Let me go ahead and write it down. M equals negative 6 over 7. Raise your hand if you disagree. Raise your hand if you agree. All right, you guys got the hang of it. Okay, so that is correct. Our beautiful slope is negative 6 over beautiful 7. Now, how do we know? It's written in slope-intercept form. So y equals mx plus b, where our m is going to be negative 6 over 7. Therefore, it has to be the same slope. And we have our beautiful slope identified. Okay, ready to step it up, guys. Let's step it up. I think we're ready. Okay, we're going to go ahead and use the next form, which is standard form. This one's a little bit different because it's not written in slope-intercept form. Our y is not isolated. Therefore, we are in charge of doing that work for this example. Okay, so we are going to isolate y ourselves. Now, here's a general form, or basically the standard form. And the way that we isolate y is that, notice here that we have x or ax in this case. In order for me to isolate y, I'm going to go ahead and do the inverse operation of ax. And it's being multiplied by b. I'm going to do the inverse operation of b in this case. So I'm going to go ahead and subtract ax on one side, subtract ax on the opposite side. I'm left with by equals, instead of writing c first, I'm going to write negative ax first. And I'm going to add c. What's happening to my beautiful y? It's being multiplied by b. Therefore, I'm going to divide every single term by that b. All right. So I'm left with y equals negative a over b x plus beautiful c over b. Okay. All right. Ready? This is just a general form. Let's go ahead and put some values into it so it can be a more concrete example. Let me go ahead and clear. Does everybody have that? Yeah. Okay. All right. Like that. Yeah. Okay. Ahora sí. Clear. Let's go ahead and try the first one. Identify the slope of the line parallel to the following equation. Let's go ahead and try A. 2x minus 3y equals 15. So, what form is this equation written in? Go ahead and tell your neighbor. Andrew, what form is it given in? In standard form. Now we have to make it into what form so we can identify the beautiful slope? Slope-intercept form. All right, when the past returns. So because we have to change its beautiful written, or we have to rewrite it, we have to do inverse operations so we can isolate which variable? Y. So how do we isolate Y? Subtract 2a. So let's go ahead and subtract 2a on both sides. Subtract 2a. So I eliminate from the left side. I now have 3y equals, instead of writing 15 minus 2x, I'm going to write negative 2x plus 15. I want it in that format. Now what's happening to my beautiful y? I'm multiplying by 3, so I'm going to divide every single term by 3. Okay. So we're left with y equals negative 2 over 3. X, do not forget the x. 15 divided by 3 is 5. All right. So now that we have it in slope-intercept form, what is the slope parallel to that line? Go ahead and tell your neighbor. All right. Alessandra, what is the beautiful slope parallel to that? Negative 2 over beautiful 3. So we're going to go ahead and identify the slope that's the same. And it's negative 2 over beautiful 3. Okay. Try the next one by yourself, guys. Negative 3x minus 5y equals 5. Let's see what you guys get. Try the next one. Ezekiel. All right, Ezekiel. So what's my first step? How do we rewrite my equation so that it looks like it's slope-intercept form? So what's my first inverse operation? So for example, here, how do we start isolating y? That's 5y's right here. What, like for example, right here, this is our first step. So eliminate negative 3x. So by doing the inverse, we are going to add 3x on one side, add 3x on the opposite side. Okay, perfect. We're left with negative 5y equals, what do we write first? 3x. Oh, plus 5. There you go, plus 5. Okay, Ezekiel, pass it on. Marco. Next step. Divide by negative 5 every single term. And we're left with y equals 3 over 5 negative. So put your negative sign in the front. X and then what? What is negative 5 over 5? Can we simplify that a little bit further? Negative 1. So it'd be negative 3 over 5x minus, you said it right now, minus 1. There you go. Minus 1. All right. So we found our beautiful equation. What is the slope parallel to that one? Marco, pass it on. Negative 3 over 5. Raise your hand if you agree, guys. That is correct. Negative 3 over 5. Let's go. Awesome. Okay. All right. Let's move on. You guys ready for the last one? Ready for the quiz already? Okay. So the last step that we have here, guys, is our point slope. Did I go over this one? Yeah, I went over this one. So my next one is point slope form. For this one, when the pass returns. Now for this one, guys, we need to make sure that we establish something. We need a point, and we need a beautiful slope. Now, when we use this form is because we're going to go ahead and write an equation given a slope and a point. So those two values or those two items are going to be given to us. Now, my point here is only one. Here's my y value. Here's my x value. And my slope is m. It continues to be m. So this is my slope. And here are my points. So here's my point. Here's my y value of my point. And here's the x value of my point. Perfect. Okay. Now, something that I want to advise you guys or tell you is that these values, y by itself, we do not substitute. Do not touch those, basically. Do not touch, do not substitute these. Do not. Do not. That's a do. There you go. Do not. Do not substitute. Do not. There you go. Sub. Basically, do not touch them. Do not substitute them. Do not do anything with them, but leave them by themselves. Make them be part of your equation. So we're not substituting anything there because we already had substituting something on our point selection or your point variable and also in your slope here. So with that said, you guys ready? Okay. Now, my next example, my first example, I'm going to write an equation now, which is what we wanted to do today. Write an equation in slope-intercept form that is parallel to this beautiful line. Y equals 3x minus 1 and passes through the point -2, -4. So we're going to take it step by step. We're going to go ahead and write the equation in slope-intercept form. A line parallel to y equals 3x minus 1 and passes through a point -2, -4. Okay. Ready? No. Okay. All right, here we go. Ready? Now, what do we need here? Which form are we going to use this time? A point and a slope form. So let me go ahead and write it down so we can have it. We have y minus y1 equals our slope inside parentheses x minus x1. Okay, now all we need is a point and a slope. Do we have the point? Yes, I have my point. I'm going to go ahead and make this one x1, y1. Do we have a slope or can we derive a slope? Yes, from what? How can we find a slope parallel to that line? It's exactly in the beautiful equation. So what would be my slope here? It would be 3. So do we have a point and a slope? Yeah. Yes, so let's go ahead and write our beautiful equation now. So my equation is y minus, what's my y1? -4. Equals, my slope is 3, parentheses, x minus, what's my x1? -2, close your parentheses. Okay, our next job is to simplify and isolate y. So let's go ahead and simplify. My left side, how can I simplify? I do the key change flip. And what happens over here on my right side? I need to distribute that beautiful 3. So I have now y plus 4 equals 3 times x is 3x and 3 times beautiful 2 is +6. Okay. Do I have y isolated? No. What do I need to do in order to isolate y? Subtract 4 on both sides. So we're left with y equals 3x plus beautiful 2. Woo-hoo! And I have my equation parallel to that beautiful line. Not too bad, huh? No? Okay. All right. I'm going to go ahead and give you guys one more to practice on your own, and then Andrew. Okay, let me go ahead and give you guys one on your own. Do you guys need this over here? No? Okay. Let me go ahead and save an image. Let me erase so you guys can have at least the y-intercept, the slope, the point slope form. And here's your turn. Go ahead and try this one. Line parallel to y equals 4/6. Goodness gracious, 4/5x plus 9 and passes to the point 5, 1. Let's see what you guys get.